Hello, how are you guys? Hope that you are doing well. So today our topic is about direct stiffness method, in which we are going to discuss about the indeterminate structure solution. What is direct stiffness method? It is the matrix method that make use of member stiffness relation for computing member force and displacement structure. The direct stiffness method is a most common implementation of the finite element. Basically we are finding in the direct stiffness method two things. One is forces and other is displacement. There are many methods to solve indeterminate structure, but for many members, if we are solving 1 to 2 members, then we are using force method. But when we are solve many member 3, 4, 5, 6, and furthermore a large structure, they are more difficult to solve with the help of force method. So we are using direct stiffness method, which is solving by in the form of matrices. Okay, so this is the formation of matrices. These all are the derivation, which I can't cover in this video, but we are direct solving from the formulas. We just have need to solve this. So we have need to just remember these two formula initially. If you have need to remember how this formula comes, then you can also see this derivation. This is also available in structure analysis book, in which I link given in the description if you are asking to me. So just remember these two formula, L cos theta and m is equal to m cos theta, x2 minus, this is for horizontal and this is for vertical component. So this is all how these formulas are come. So this is the main equation which we are using in the direct stiffness method. How this equation come, I can give short an idea, which is this Lm and Lm here is minus, and if you can remember this equation, then you can easily derive this one. So don't need to remember or any type of this equation, just make mindset concept this one, so you can solve this matrix by multiplication, this one. So this is the main equation, you must have need to remember it. So this is the example which I get from R.C. Hibbeler book, which is very famous. So we are solving direct stiffness method example. Determine the structure analysis, structure stiffness matrices in for the two members across. We are solving initially 2 members, then we are moving step by step to difficult member. So the members length, horizontal length, all lengths are given. If you have required this inclined length, then you can use Pythagoras theorem. You have base and height, so you can find inclined member hypotenuse scale is equal to base scale plus perpendicular scale. So this is the member 1, so we are solving member 1 first. So this equation is lambda x. Initially you just have remember lambda x is equal to L and lambda y is equal to m. So these are many terms which you using different we are using in book, then it's using lambda. In the other book we are using L. So you must have need to remember these two terms. So lambda L we know that L is equal to x2 minus x1. So which I have remembered my first remembrance formula, x2 minus x1, and this is y2 minus y1. So x2 minus x1, x2 it is x1, it is x2, Okay, this is x1, this is x2, this is x1, this is x2. So x2 is equal to 3, x2 is equal to 3, and x1 is equal to 1. So 3 minus 0. So member 1 is only horizontal, so there is no vertical force in member 1. This is our member 1, no vertical force, but just lay down it here, so no vertical member, so it's 0 by 0. So y2 minus y1, 0 minus 0. So when you are putting this equation here, you have need to divide this answer to L, because this equation is AE divided by L. So if you divide this initially, then it will make very easy to you. So 1 divided by 3 is equal to 0.33, same as it is L square. This is L square here, and divided by 2, divided by 3L divided by this one, and same as it is LM. This is L, this is M. 1 multiplied by 0, it's 0. So here same as it is L square, 1 square 1, and divided by 3, so it 0.33. Same as it is, you can follow this equation. So this is member 2, same as it is L x2 minus x1. Member 2 for member 2, x2 is this distance, this is x2, this is x1. x2 is 3, x1 is 0. 3 minus 0, same as it is, and y for member 2, y is 4. How I can explain? This is member 2, y1 is this point, and y2 is this point. y2 is equal to this height, y2 is equal to 4, and y1 is equal to, basically y1 at member first point position, and y2 is second point position. So y2 is 4 meter above, and y1 at initial 0 point. So we got 4 minus 0, and its length we have calculated by Pythagoras theorem. We know base and height, so we calculated it's 5. Okay, so L is 5. We are dividing 0.6 square, this equation 0.6 square, and divided by 5, so 0.075. Same as this is L and M multiplication, L and M, 0.6 multiplied by 0.8 and divided by 5, so we get 0.09. Same procedure which we have followed in this equation. So now we have solved K1 plus K2. This is K1 equation, this is K2. K1 is for member 1, which and K2 is for member 2. So at this equation you have need to identify what's, so we get K1 and K2 value. Okay, so now we make general equation. How we put this K1 value, this is 1, 2, 3 and 4, so put simply 1, 2, 3 and 4. Okay, remaining put 0 because we don't have 5 and 6. Okay, same as this. K2 is this, put 1, column 2, there is no have third column, so put third 0, 4 be 0, and then 5 value and 6 value. Same as this, which column you don't have number and their values, put simply 0 value. We have put K1 and K2, so now we are going to add them. It's K 0.33, 0.76, we add this and this value, so we get this. Simply as it is, we are just add the value and we make general